Okay, so this is the last quiz of the semester, and it's basically how does this successive approximation ADC converter work? We went through this in a lecture earlier today, actually. So you start out. This whole thing starts out by placing a digital signal of 1 on the most significant bit. So we would have a 1. Let's see. So on the most significant bit, we get a 1, 0, 0. Now the voltage that comes out, so in other words, we have a 1, 0, 0 here. So it'll be 4 divided by 4. So we get 1 volt that comes out. And the input voltage is 1.35. So 1.35 is bigger than 1. So we'll go ahead and set that bit. So the source is 1, 0, 0. Now we move to the second bit. And so at the SAR we have 1, 1, 0. And now now we get, from this formula, we'll have a 1, 1, 0. So we'll have 4 plus 2 is 6 divided by 4. So that's 3 halves or 1.5 volts. And 1.35, now when we do the comparator here, 1.5 is bigger. And so that bit does not get set. So the SAR still reads 1, 0, 0. And now the last bit gets set, 1, 0, 1. And we come back up here and we have a 1, 0, 1. So our little formula now is 5 divided by 4. So that's 1.25 volts. And 1.25 volts, now when we do the comparator, is less. So that bit remains and gets set, 1, 0, 1. And that means that 1.35 is approximated as 1.25 with a 3-bit digital to analog converter. Okay, so that's how to do quiz number 47.